All right, in this lesson, we're going to learn about using integrals to find area between two curves. So the first step is find the points of intersection. I'm going to use A as the x value in the first point of intersection, or the leftmost point. Right, we read our graphs left to right. I'm going to use B as the x value in the second point of intersection. The area between two curves is calculated by the integral between A and B, the points of intersection, the x values of the points of intersection, and we take the top curve minus the bottom curve. dx. dx meaning we're going left to right. A and B are both in terms of x. As we look at the region from left to right, one of the curves, one of the functions will be above the other function over the whole region, not over the whole domain, but over the whole region that we're calculating the area of. Now, I want to show you something that's not part of your notes, so just watch. This sounds like new information, and it's really not. We've been calculating area using integrals. In this graph, we've got f of x, our function. If I wanted to find this area, which is below the x-axis, I would set up, let's call this area R, region R. The area of R will equal, we're going to go from -2, x equals -2, to x equals -1. Now our top function is the x-axis. So we're finding the area between the curve and the x-axis. So the top function has the equation y equals 0. So top function minus bottom function dx. So when we've seen this, that negative has come out front. So we're finding the area between the x-axis and the curve. We have already been doing this, but we've been using 0 as our other curve. Y equals 0 as the other curve. So negative telling us it's below the x-axis. Let's look at the other region. This region is above the x-axis. Let's call this area S. So if I want to find the area of S, I'm going to go from -1 to 0. This time my top curve is f of x minus my bottom curve, which is the x-axis, which is the horizontal line y equals 0. So it just looks like the area from -1 to 0 of f of x dx. This we've been doing already. We've already been calculating this area between the curve and the x-axis. We just didn't realize that we were subtracting from 0 or subtracting 0. So when we're calculating the area between two curves that live in the plane, so now we're not using the x-axis, we're using another curve. So looking at example 1, it says let R be the region bounded by the functions f of x equals x squared. Well, the first step is to determine which of these functions is f of x. Well, if it's x squared, that's the then that's the parabola. And g of x equals 4. G of x equals 4, that's a straight line through y equals 4. So now, only looking at the region R, we can see that g of x is above f of x in that whole region R. So we're going to set up our integral. Our top function is g of x, and our bottom function is f of x. The points of intersection are -2 and x equals +2. So now continuing to solve this, from -2 to +2, g of x is equal to 4, f of x is equal to x squared, and now we can just use the power rule and the second fundamental theorem of calculus to solve for this. We're going to add 1 and divide, and then evaluate from 2 to -2. So we'll have, just write it out, sub in 2, the upper limit, minus sub in -2, and then we just have some algebra to do. 8 minus 8/3 minus -8 minus -8, so that's going to be plus 8/3. So we have 16 minus 16/3. Make 3 my common denominator. 16 times 3 is 48. Minus 16/3, so that leaves us with 32/3 is the area of region R. So top curve minus bottom curve from the leftmost x value in the point of intersection to the rightmost x value in the point of intersection. Okay, example 2, calculator level 1. So R is the region bounded by the functions. Again, if f of x is a squared function, then that must be the parabola. And g of x equals 3 is a straight line through y equals 3. So g of x is above f of x in this whole region R. We need to know the points of intersection. And we'll use our calculator to find those exact values. When I find them, I'm going to set the x value equal to a in the leftmost point of intersection, and the x value equal to b in the rightmost point of intersection. So I'm going to go ahead and set this up algebraically before I use my calculator. So I'm going to go from a to b. G of x is the top function. F of x is the bottom function. So, pulling up my calculator, I'm going to sub f of x into y1, 3x squared minus 10x, and g of x into y2, graph, by my first point of intersection, You go near it, hit enter 3 times. As soon as the point of intersection pulls up, if you go back to the home screen and immediately store that value as A, we don't have to round off that number. Go back to the graph, find the second point of intersection. Go near it, hit enter 3 times. Point of intersection is pulled up. You go back to the home screen and immediately store it as B. Now, if I look back at the equation I have set up, I have g of x in y2 and f of x in y1. So to type this in, I'm going to go to math number 9 to get the integral to pull up. I'm going to start at A, end at B, calculate y2 minus y1 by going to vars over to y vars number 1. That will pull up all the y values. So I need y2 minus y1 in terms of x. So the area of this region is 29.371. And let's do one more. So example 3 calculator, this one's the part of the level 2 on Delta Math. So the shaded region shown below is bounded by the functions f of x, g of x, the y-axis, and the line x equals 1.5. So we've got to identify all those first. F of x is a negative x squared, so it's this downward facing parabola. G of x is 3x plus 2. That's a straight line. The y-axis is a vertical line whose equation is x equals 0. Vertical lines are x equals. And the vertical line, x equals 1.5. So now, if we label our two regions, let's go R and S. In region R, f of x is the top function, and g of x is the bottom function. But in region S, it's opposite. G of x is on top, and f of x is on the bottom. So to set up our integral, one more thing, point of intersection. We need to identify the point of intersection. Point of intersection is here. We'll have to use a calculator to find the value. Either way, I must store it as A. So we're going to go from, so the area of R, we're going to find the area of R and add it to the area of S to find the total area. So the area of R goes from 0 to A. My top function is f of x. My bottom function is g of x. My integral is in terms of x. The area of S, I'm going to go from that point A to x equals 1.5. And this time, g of x is the top function. F of x is the bottom function. Again, I'm in terms of x. So let's use our calculator to find this point of intersection. I'm going to put f of x into y1. And g of x into y2. So I'm going to find this point of intersection. Go close to it, hit enter 3 times. Intersection is 0.7. Back to the home screen. Immediately store it as A. So I put f of x in y1, g of x in y2. So now I'm going to go about typing this in. Go to Math 9 to get the integral to pull up. I'm going from 0 to A. I need y1 minus y2. dx, that's the area of R, and I'm going to add it to the area of S. This time starting at A, ending at 1.5, and I need y2 minus y1. Again, in terms of x, this area, rounded to 3 decimal places, is 3.940. And that's the lesson on the area between two curves.